Hello guys, long time no see. This will be a short video, I hope, where I'm going to show how to save your buffers in the Cube IDE and how you can plot them. This approach works for other microcontrollers too and other IDEs, but I'm going to focus on the STM32. I created here a project for the F407, but it's only an example, so don't worry about this. It will work for any STM32. In this project, I am only generating a sine wave and a cosine wave, and then I'm going to save those buffers, and I'm going to show how to plot them. So here I'm saying here that I have two buffers and each one of them has 1000 points. So I'm generating it here. It's of type float. I'm calling it my buffers, and then I have an auxiliary variable here to generate the angle. So let's go here to the main function. Everything is set to default here. I didn't change anything, not even the clock. So here we have the routine to generate the sine and the cosine waves, and here we have the generation of the angle. Don't worry about this. It can be anything. It can be inside a function where you want it. Don't worry about this. It's only a simple example. And then after your routine, you have to set a breakpoint. In this case, since I'm inside the main function, and my routine is before the infinite loops, I'm going to set it to the beginning of the infinite loop. So here. And then I have a folder called scripts, and then a plot buffers.py. It's a Python script that we're going to use to plot. So we debug the code. You must have your board connected, your debugger connected, and then you have to open the debugger console here below here. If it is not showing here, you go up here, window, and then show view, and then you open debugger console. Don't forget to set the breakpoint. So run your code, and then it will stop in your breakpoint. And then we have a command here. We can input a command here. So we have I found this web page. I'm going to put the link in the description. It shows how to use the GDB debugger console. So you have here the dump command. The first argument that you use is the format. There are a lot of formats that you can use. I'm going to use binary because I believe it's the most simple. So, and then you have to set the next argument is memory or value. If you use memory, then you have to provide a start and a named address. But if you use value, you can use only the name of the variable or the name of your buffer. So we are going to use value. And then file name, it's where you want to save your file together with the name of your file. So here we have the different formats, binary, IHEX, SHEX. We're going to use binary, as I said. So I will provide this script for you in a gist. So you have here, this is the command that you're going to use. When you run the script, it will print here the command. So it's here, dump binary value I'm going to save the binary file inside the scripts folder, and then my buffers, that is the name of the buffer. So let us see. Let's go back to the cube IDE, and then let's paste the code here. So the code is here. So we already ran the code. When you look now at the when you look now in your folder here, in your directory, you have now a buffers.bin file, because I called it here buffers.bin. And then when you run your script again, it will plot the results. So we have here the sine and the cosine. Now I'm going to show you what is inside this buffer. Sorry, this script. We have to use this. We have to import the struct, because this is how we're going to interpret the binary values that we're going to read. And then we will use matplotlib to plot the buffers, and OS and sys for opening to get the path and so on. So we have to provide here the number of arrays that you're going to use and the number of points. I have here a read binary. This is the function responsible for reading the binary file. So we provide here the file name, and then it will open the file and use unpack that binary values, each 4 bytes. We have here file.read4. We're going to read 4 bytes and then interpret that as a float value. And then we're going to append that value in a list. And then return that list at the end. And we have a plot buffers here. If you're going to use these scripts, the only thing that you need to do here is to modify the plot buffers function. So you're going to plot the things that you need. So here there is another backslash, here also backslash. So here, if you have 3 buffers, you're going to repeat, for example here, and then you can generate multiple figures. The things that you want, you're going to do in this function. You don't need to change any of the other functions. So we have also a main function. The first thing that it does is print the useger, and then it reads the file and then plots it. So that's it. Nothing else. But how can we save automatically the file? Because we don't want to import that command every time that we run this script. So we can do this. It's very simple. When you set your breakpoint, like here, right click it. So you go to breakpoint properties, and then here you click new. You go here to actions and then click new. You then give it a name, so dump command, let's call it dump command. And then you, in action type, you change to debugger command action. And then you paste here your command. So let's type OK. But that it's not only that, you have to click in attach so that it goes up here. Okay. Let's change the name. I don't know why I changed dump. Okay. Apply and close. So to show you, I'm going to delete this file. And I'm going to run again. I'm going to debug. Oh, sorry. We don't need to have the debugger console open now because it will run automatically. And then when you run the code, it will automatically save the buffers. So you can see here that's here again, and we can plot it. So it's here. That's it. But remember that this only works in debug mode. So in release mode, you have to maybe use a serial command or something like a UART dump or something. Maybe if you want, I can make a video on that, but it's not that simple because you have to create a protocol to guarantee that we won't lose any of the data, we won't corrupt the data, because if you miss one byte, everything will be wrong. But if you want that, we can do it. But that's it, guys. I hope you liked the video. So until next time.